add or subtract matrices, you have to have the same order so that every corresponding entry has something to add or subtract with. Okay. No entry could be left alone and not have anything to add with. Well, the rule is different for matrix multiplication. So in matrix multiplication, you're allowed to multiply two matrices if the number of columns in the first matrix matches the number of rows in the second matrix. So ideally, if you're asked to do some matrix multiplication, I would say first thing I would do is write out my orders for the two matrices. And I want to confirm that the columns in the first matrix will match the rows in the second matrix. So it's really like when you're writing it out, like if you have matrix A times matrix B, it's the two middle orders that need to match. So you're going to see this anytime you see a textbook or like definition online. If you're in another class and you're doing matrices, my P doesn't show up very well, so I'll show up the lights real quick. Color-coded them. But you're going to see this over and over again every time you see a matrix. If A is m by n, so m rows, n columns, and B is n by p, n rows, p columns, then you can multiply them because the columns in the first matrix matches the rows in the second matrix. And your product will have the dimensions m by p. So once you decide like the columns in the first and the rows in the second match, then I call them like the bookends. The bookend orders, M and P, that's going to be the dimension of your new matrix. So it is possible to multiply two matrices with different orders, and your answer could be an entirely different order as well. Okay, so my first set of examples, I don't know that you necessarily have to write these down. They're just an opportunity for us to talk about like this piece right here, like are we allowed to multiply them and what will the dimensions of our answer matrix be? So it says state the order of A and B. Okay, so give them individually. Does the product AB exist? Like can you multiply them? And if you can, what are the dimensions of your answer matrix? So real quickly with your pods, see if you guys can determine the order of A and B, and then decide if you can multiply them or not. Go ahead and talk it out with your pods. So the order of A. Let's see, Tommy, what's the order of A? 4 by 1. Ryan, what is your order of B?
1, 7. 1 by 7.
1 row
Yeah.
and 7 columns.
No, what column? 7 rows. Rows by columns, right?
Yes. How many rows?
1,
How many columns?
7.
1.
2? I don't know.
It's okay.
I'm confused now.
Okay, so remember from yesterday, it's fine, we want to clear it up. Remember from yesterday, rows are things that are horizontal, right?
Yep.
and columns are things that are vertical.
Yep.
And this one can be kind of tricky because when you have only one row, a column is really just a single entry. So this is your first column, and this is your second column. But you don't have any other entries beyond that. So this one's going to be a 1 by 2. A 1 by 2 column. Okay, can you multiply them? Alyssa, can you multiply them? Yes, because remember, you have to make sure the columns in A match the rows in B. Do they match? Yeah. Okay. So that means that my answer matrix A times B is going to be what dimension? Anybody think they got the dimension? Who said that? Alex? 4 by 2. Okay. Then, if these things match, remember, go to the bookends. It's going to be a 4 by 2. So that means it's going to have 4 rows and 2 columns. You're going to have 8 separate entries when you multiply those. And we'll do that on the next slide. Okay, my next example. Let's see if you can identify the orders. Is it possible to multiply these matrices together? Go ahead and chat it out with your pods. Talk to each other so you can agree on answers.
Yes.
Find the order of A and the order of B.
By 3. Oh yeah, the answer is. Oh, wait, no,
3 by 2.
Okay, Abby, do you have an order for A? 3 by 2, right? It's horizontal first, then vertical. So this is a 3 by 2. Let's see, Madison, order for B. 1 by 3. Can you multiply A times B? No. When you check the columns in A and the rows in B, they don't match. So you can't multiply. Product of AB does not exist. Not possible. Anything like that is a fine answer. Can't do whatever. I'm cool with that. Could you multiply B times A? Yeah. So it's possible, like one way I can't multiply, but the other way I can. Because if I did B times A, that would be a 1 by 3 and a 3 by 2. And then the columns of the first matches the rows of the second. I can multiply them. The answer dimension or order would be 1 by 2. Okay, so that means that if I multiply these two matrices together, my answer is going to be one row with 2 columns. There's just going to be 2 entries in my answer. All right, let's do an example where we actually multiply. Okay, I would jot this down in my notebook. Right. So the directions will say multiply. Sometimes they'll say multiply if possible. Remember, you can't always add, subtract, multiply every matrix. Okay, it depends on their orders. Okay, now think about their orders. We should be getting better. Order for the first one, not too bad, right? That's square, so it's 2 by 2. Order for the second one, 2 by 3. 2 rows, 3 separate columns. Can you multiply them? Yep. Okay. The columns of one matches the rows in the second. And the answer matrix is going to be 2 by 3. So I'm going to mark that down. Yes.
How's it 2 by 3 if the two numbers are twos?
Well, these things match, so I can multiply, but the dimensions of my answer matrix come from the bookend numbers. Right? If you go back to that definition, it says if A is n by n and B is n by p, then you can multiply them and their answer is n m by p. Yeah, the outside numbers. Okay, so this is the first time we're going to be multiplying. I'm going to give you a little hint here that maybe you want to jot down. When you multiply matrices, this is what you're doing. You're multiplying rows in the first matrix by columns in the second matrix. Okay. So it's a row by column multiplication. And when you're multiplying them, okay, you're going to like multiply the corresponding entries. Which is really like the first times the first, the second times the second, and so on and so on. It just depends like how many entries does each row and column have. Okay, so if there's like 6 entries in a row and 6 entries in a column, I'll have to multiply 6 numbers together. And then I add those up. Okay. So just to get one single entry in your answer matrix, you have to multiply all corresponding entries in a single row and column, add them up, and that sum goes in the first spot. Okay? And then you move to the next spot. So I'm going to copy down, because I'm running out of room, I'm going to copy down my matrices. So I got what, 3, 1, and 4, negative 2. Can you read me the first row, the second one? What is it? 2, 1, 0. And
3, negative 2, 4.
negative 2.
No, 3, negative 2, 4.
3, negative 2, 4. Did I get them right?
Yes.
Okay. Sorry that looks like 21, but that's 1 over there. Okay, so here's what we're going to do. Our answer is going to be a 2 by 3, right? So I'll have 1, 2, 3 entries, 1, 2, 3 entries, 2 by 3. I mean, I'm going to come up with 6 numbers. To get those numbers, I'm going to take the first row, 3, 1, and I'm going to multiply it by the first column. Okay, so you're taking one thing that's horizontal times one thing that's vertical. Imagine in your mind, you're going to turn that 3, 1. So you take 3 times 2, which is 6, plus 1 times 0, which is 0. So 6 plus 0 is 6. Oh, sorry, I thought that was, I don't know what I was doing. Yes, okay. 3 times 2 is 6. 1 times 3 is 3. So the answer should be 9. Sorry about that. I thought I was looking at it, but I was not. Okay. Now, to get the next entry, I just kind of go like down the row. So I'm not done with the first row because I've only taken the first row times the first column. Now I need to take the first row times the second column. Okay. So remember, you do it like corresponding entries, first times first, second times second, and add them up. So 3 times 1 is 3, plus 1 times negative 2 is negative 2. 3 plus negative 2 is 1. I want the first row, third column entry. So in the matrices, I'm going to take the first row times the third column. So I just got to kind of like move through the whole matrix to get that whole row. 3 times 0 is 0 plus 1 times 4. 4. Okay, so we took the first row, we multiplied it by every single column individually, which gave us our 3 columns in our answer matrix. How are you going to get that second row in your answer matrix? Do the same thing with the bottom row. Okay, so I'm going to give you some time now. See if you can take this second row for negative 2 and multiply it through each of the 3 columns to get your answers. If you're having like a hard time seeing this, call me over, because sometimes you need to see it like right in front of your face on your paper. So let me know if you're having trouble. Yes. Yes. First entry by first entry. Second entry by second entry. But one's a row and one's a column. Okay, I'm seeing lots of good work as I go around. 4 negative 2 times 2, 3, so that's going to be 8 minus 6, 2. Then 4 negative 2 times 1 negative 2, that's going to be 4. Careful here. Plus 4, 8. I know I saw some people with zeros, so that's just a small sign error. And 4 negative 2 times 0, 4, so 0 minus 8, negative 8. Okay. Questions, concerns? Okay. Next one. You know, maybe you're doing your homework. Good idea. Well, I guess you have the worksheet, so it's not like you have to write down from the book. But I would always just kind of glance at it like, can I multiply it? So what's the order here? 3 by 2. 2 by 2. I can multiply. So yeah, I'll go ahead and start doing all the work. If you plan ahead and you think about the order of your answer, it makes it a lot easier to get the correct answer. So the answer is going to be what dimensions? Another 3 by 2. If you know it's 3 by 2, you know it has 6 entries, right? 2 entries per row. And there are 3 rows. So I like to kind of just like think about that, like so I know at some point I gotta write down a number. Remember, this is a row by column multiplication. So I'm going to start first row times first column. 2 minus 6, negative 4. First row, second column. Negative 6 plus 12, 6. Now I gotta move on to row 2. See if you can get the other entries for me. Stop me if you have a big question you're really lost.
It's like the first row, and then so like the first and the first one, and the second and the second one, the first and the first one, and then we like do this one and this one, and then subtract add into the ones.
So if you ever need to go back to check like this is the second row. So you're okay, to get my second row, I'm getting negative 1 plus 8. That's 7. That's 3 minus 16. Negative 13. Third row, negative 6 plus 0, negative 6. 18 plus 0, 18. Questions, concerns? Okay, I'm going to give you the last 10 minutes to work on the assignment. Then that way people who specifically have a question or an issue with their multiplication, setting it up, knowing what your answer matrix looks like, you can ask those kinds of questions. And remember, we're now done with matrices. Tomorrow we're going to review and practice, and on Thursday we're going to take a quiz.